All right, it's 10:15. We're ready to go. Thanks for coming. We have some space in the front if you like to sit closer. Now, given that we don't have like a ton of people, we're obviously going to do the session. No question. Please feel free to ask questions. If stuff is boring, you want to talk about something else, please ask. We can try to make it a little more interactive, depending on what you've seen before or not. So my name is Jan Engelsberg. I'm a senior program manager in the Azure Data team running the open source database offerings. Both the MySQL and the Postgres services, and we are in the process of getting MariaDB onto the service as well. With me today is Andrea. She's also on the team, and then we're going to have a guest speaker, Anil, who's going to talk about his experience running on our service. All right, so you probably have seen this or heard it, like the service is now generally available. Who of you has used the service or is using the service? Andrea is, very nice. And Anil is, that's good to know, because he's going to talk about how he uses it. So the service went into general availability in March the 20th, and is now backed by our SLA since then. The service right now is available in 24 regions across the world, and so we're not yet covering the full Azure footprint, so we don't yet have the full Azure reach, but we're basically ramping up on it and onboarding the service to more regions with the goal, obviously, of being available in all regions across the world. All right, so when we introduced the open source services, like what was our thinking around that and why are we doing this? So first of all, we're running the community versions of MySQL, and we run them as a managed service for you, right? So it's not an IaaS offering where we just give you an image or anything. It's a managed service where we run the community versions of MySQL for you. Then, given that we are Microsoft and Azure, everything we do is geared towards being enterprise ready, right? So these services, we made sure to provide you elasticity in terms of scaling, right? So cover a wide band of resources available to you, as well as make these services highly available for you. The next pillar of being enterprise ready is being secure and compliant, right? If you think about banking or healthcare, thank you very much. If you think about banking or healthcare, like obviously security is super important, right? And it's rather difficult for yourself to run a service that is compliant with different standards that you have to be compliant with, and we provide these compliance for you. And then lastly, as we just seen on the previous slide, Azure itself is industry leading in terms of reach across the world with the regions that are available. And obviously, as we onboard to all of those regions, these services will be as well. And then lastly, Microsoft has a huge portfolio of very powerful tools in the service itself. And what we're doing is we're integrating those open source databases to be able, or for you to be able to essentially take advantage of the other tools that exist by using those open source databases. So let's double click on a few of those. So why do we run the community version and what do we mean by managed? So like if you, like who has set up MySQL, played with it, runs it even? Okay, so all of you do this, right? You do it in a VM, presumably, or on premises. So, you know, it takes installation, you need to do maintenance, you need to configure this potentially based on the size of your virtual machine. Then at some point you need to think about high availability. How do you do it, right? You need to set up replication. You probably need a witness that observes the primary, fails over to the secondary, right? So these things can very quickly get very difficult. Then you get into things like, hey, I need to apply a security patch, right? Either for the operating system or for MySQL itself. How do you do this? How do you orchestrate this? Like what do you do about downtime, right? So what a managed service provides is essentially taking all these responsibilities away from you, and we provide this out of the box for you. Meaning we obviously take care that the operating systems are up to date and patched, right? And they're not even exposed to you, so you wouldn't be able to do it anyway, right? Then we make sure that MySQL gets the latest patches in terms of security, and we do minor version upgrades whenever they come out, roughly within a month of after they come out. And then obviously we, as we enrich these offerings, we apply those patches for you as well. That said, we don't do major version upgrades for you, just simply because they are potentially breaking in nature. So this is something where you would have to basically take a manual step and upgrade to a next major version. And then the second thing, the community. Why do we use community MySQL? For us, it was one of the key principles from the very start that you shouldn't have to change anything that you're doing today, right? So if you are running on a MySQL community edition, wherever you come from, you probably have an ecosystem around it, right? You have a stack of applications that use them. Our goal was to provide a MySQL service that can one-to-one run these databases just simply in the cloud in a managed fashion, right? And then as part of the Azure platform, you'll be able to run the ecosystem that you had in either on-premises, a different cloud, or an IaaS, obviously, as well with our service. Those are the key ideas when we introduced a managed service running community edition of MySQL. And yeah, as I mentioned earlier, so MariaDB is not yet available. It's in private preview, and this will go into a public preview later this year. So then I mentioned before elastic scaling and the ability to change your resources. And so what we do on the platform, actually, we use the same mechanism that provides the high availability for you to also let you scale your resources in a fast manner. And the idea behind this is, other than running in a VM, where if you want to actually change your resources, similar to applying patches, right? Typically you would have to run in a high availability setup. You potentially need to change the secondary first, then change the, fail over, change the primary, fail back if you need to, right? If you run a single VM, you potentially take a multi-minute outage. If you change the compute, just simply because the VM needs to be shut down, a new VM is going to spin up, which just takes time because there's operating system booting and so on happening. And you take the outage for this, right? Our service utilizes, again, the high availability mechanism that we've implemented, and I'll talk about a little more later, to let you scale very fast. And I will show you. And the advantage of this is that you can provision the resources based on the demands of the database, right? So a typical scenario would be, hey, you know that your workload is busy during the day, during working hours, right? But it's almost or close to idle during night and on the weekends, right? So what we allow you to do is to basically scale up the database in the morning, let it run throughout the day at a higher configuration, scale compute back down in the evening, and ultimately what this does is save you cost in the whole process, right? Obviously, this works better for predictable burst than unpredictable burst, but I'll also show you how you, also later on in a quick demo, on how you can do this reactive actually based on demand that is unpredictable. So let's have a quick look what this can look like when I mean with scaling. So what you can see here on the screen is I have a MySQL database set up in our service. And on the top left here, what you see is a workload that runs against this database. And what this workload does, it does huge updates on the system, right? So these are multi-megabyte updates that are constantly being written against the table. And you can see here the rate of the transaction, we get like 0.7-ish, right? And the average transaction time is about 35 seconds running there, right? And so this workload has been running since last night, so that's pretty much what the service does. So now what I'm going to do, actually make sure that also refreshes here. Has it changed? Okay, yeah, no, it's still running. It just changes very slowly. I just want to make sure that it works. So what I'm going to do now is I'm going to scale the storage of the MySQL database. So how it works in our service is that with the amount of storage that you provision, the I/O that you get increases, right? So there's a ratio of roughly 3 to 1. And so if you scale up the storage, you'll be able to get more I/O performance. So do here first is MySQL, AZ MySQL server. And let me just list the server that we have right now. Build scale demo. So you'll see the configuration of the server that it is right now, which will be a 2-core. And then you see the storage megabytes. I hope you can actually see it. That is right here is 512 megabytes. So this is 5 gigabytes, which is the smallest that we allow you to provision. What I'm going to do is I'm going to update this MySQL server. And if you're familiar with the CLI, you need to always give it the resource group that is in, which is build scale demo. You need to tell the command which server you want to upgrade, which is the MySQL build scale demo, I believe. We'll see. And then what I want to change is the storage size. And so now, obviously, I forgot out of my head what is 2 terabytes, which is the max. So let me just actually, one sec. Does anybody know by any chance 2 terabytes in? Yeah, but that's not precise enough, Sunil. So that's it, okay. Paste the command back in, and so 2097152. So that's 2 terabytes in megabytes. And hopefully, when I issue the command, it will start no. Build scale demo. Which one is he complaining about?
You don't need the word build in the server.
Oh, it's my scale demo. Yeah. There we go. So now the command is running, and you will see actually in the workload that if everything goes well, hopefully relatively instantaneously, that the average execution time will go down and the transaction per second number will go up.
So this is while the service is running?
This is while the service is running, yes. And obviously it's a demo, so it's not working as I had intended it to be. So the command is, oh, now you can actually see it. Oh, you know what? Because the screen freezes when I zoom in. I didn't know that. OK, so you can see actually on the top left here. So the number, it was 0.7, right? And now the number is 3.0 something. And I'll zoom in a second. And you can actually see that the average transaction time is way down. So you can see average transaction seconds is now 6, right? And we get about 4 of those transactions per second through the database. So it's a dramatic increase compared to 0.7, right? And the long execution time. And the other thing that you can see, so while the command hasn't returned yet, right? Because there are mechanics in, so it's an asynchronous request that gets put into a service, that gets executed, and then the service waits for the operation to complete and come back. Right? You can see that the actual operation was more or less instantaneous on the database, and there was 0 connection drop. Right? So for scaling storage, it's a true online operation, and there's no interruption to the service. All right. Any questions on this demo? Very good. So this is an example of what we mean with basically elastic scaling, right? And being able to react to changes in demand more or less on the fly.
So it's the high, are you going to talk more about the high availability?
I will. Yeah. We already talked about, or I briefly mentioned, secure and compliant is obviously one of those key things that we do in the service. We make it secure and compliant. So if you're familiar with SQL database, there's a long list of compliance certifications that we have. We are onboarding the open source MySQL service to those as well. You can see on the slide the the certifications that we already have, so SOC 2, HIPAA, and PCI are important ones that stand out, obviously, together with the ISO certifications. And there are more certifications in the pipeline, and we will essentially onboard or get certifications for all of those that are also available in SQL database. The other point on this slide here is an important one. Who's familiar with the Azure IP advantage? Okay. So if you're a customer of Azure, what Microsoft provides is an uncapped indemnification in case of you being sued for patent infringement or essentially for license infringement. So what we say is we stand behind the open source software that we run on the servers, and if somebody comes to you and sues you for using these services and say, hey, essentially you're violating a license, what Microsoft will do is we will defend you against these types of lawsuits. And so there's only one, there are two additional points. We will defend with our patent portfolio. So there are processes where essentially if you violate a patent, well, you can say, okay, and then the other guy gets to use this patent, right? So the Microsoft patent portfolio will be available for you to use essentially in these kind of cases. And then the last thing, and that's also an important thing to note, is what happens every once in a while is that patents are being transferred to a third party. And they essentially come and cash in for it. That's not a general Microsoft practice. But obviously, we can't assure you that this will never happen. However, what we do is we give you what is called a spring license, which basically said, even if we do this, we will license the patent for you so that you are not being impacted. Right? And so these are, and I think it's essentially a unique practice across all cloud providers that we do this. And we believe this is a big part of giving you assurance that you can worry-free essentially adopt those open source services. All right, then I talked a bunch of what we did, how things look, and how they roughly work. Let me invite Anil up on stage, who works from Witty Parrot, and he will talk about how he or his company, what the company does and how they use our MySQL service. No, this guy, yep. There we go.
Hi, good morning. Thank you, Han. So we are a startup, about 4 years old company based out of California Bay Area. And we have our entire engineering team based in Bangalore. And we are closely partnered with Microsoft on the go-to-market, as well as obviously we use most of the Microsoft technologies behind the scene. We are primarily focused around intelligent communication, and also we are into chatbots and robotic process automation activities. Here is a list of customers that we have. As you can see, most of our customers fall into healthcare, which is one of the large focus area for us. The second one is the financial sector, and third one is IT companies, where the security is one of the key requirements. And most of the time, we end up deploying our entire platform on the Azure subscription of the customer itself, primarily because of the security reasons. So as I mentioned, the three focus areas for us is one is robotic process automation, where we heavily focus around the document automation in companies like mortgage companies or clinical trials in case of healthcare companies. Cognitive automation, where chatbots and digital assistants are becoming a big use case for us. Most of the financial institutions as well as large IT companies using these chatbots primarily for both sales and support activities externally facing, as well as internally for employees to enable both IT support as well as HR support. And the third focus area for is content management itself. So we are not into traditional content management, unlike SharePoint or any other solutions that you have in the market, where we more focus around conversational content, where we break down the documents into snippets of information that is tailored for end users to consume in chunks, whether it is responding to an email query or chat conversations, or it could be even, for example, when you're creating documents like contracts or statement of works or RFPs. That's where we more focus around breaking down the documents, and this is where we use MySQL behind the scenes to store all the content. Value proposition to our customers is primarily the productivity gain, where we have, through RPA as well as chatbots, we have seen a clear 10x productivity gain. And chatbots as these days are becoming, especially voice-enabled chatbots are becoming very popular, and which drives more customer experience. So the platform itself, as I mentioned, we are heavy into this micro-content automation. But what happens is when we go to the customers, typically they end up having a lot of the repositories already. They store the content. So we focus on how we can federate the content on top of their existing repositories. Plus, we also manage the repository of our own if the customer choose to use our repository, and act as a federated interface. Once we have the content in a micro-content fashion, then we apply extensive AI and ML, which we use again Azure ML behind the scene for all these AI ML activities, which I'll talk about a little bit. So once we have the knowledge in our platform, the end users would consume this knowledge either through the bots or through the widgets. So we ended up building a lot of these widgets, which are embedded inside of Office 365 apps like Outlook, Word, Excel, CRM applications like Dynamic CRM, and bots. Obviously, use Microsoft Bot Framework behind the scene, which enables this knowledge to the end users at the point of use. So the 4 solution we are focused on, one is omni-channel communication. As I mentioned, Outlook is one of the big use case for us, where there's internal employee communications, where they want to measure the engagement of employees in terms of whether they're looking at the email or not. So email tracking is one of the big focus area. This is applicable not only internal, but also in case of sales scenarios where the salespeople are always looking for these analytics. So apart from Outlook, we also focus on all other social media channels to auto push the content, but Outlook is by far the biggest one in terms of the use case. The second focus area, as I mentioned, chatbots and digital assistants. This is, again, there's a lot of solutions in the market. We kind of differentiate ourselves because, unlike most of the products in the market, is more focused on intent analysis on the customer side of the queries, whereas we also focus, in addition to that, more on the content side of intent analysis by building this knowledge graph, activity graph. We continuously profile the users, whether it is anonymous users through the web cookies or through the known users, whether it is in CRM or in HRM in case of employees, those kind of scenarios. Third one is microsites, where it truly enables collaboration with external audience. Internal audience, we obviously use Microsoft Teams because we tightly integrated our solution into Teams. But when it comes to external customers or onboarding vendors or employees or candidates, that is where we use microsites. And finally, the document automation. So this is where we process the documents all the way end to end. In case if it is a scanned images, we use the OCR, and then we apply this AI ML to extract the information and auto classify the content with metadata so that it will be ready for consumption for end users at the point of use. So as I mentioned, so we mainly focused around the knowledge automation combined with the robotic process automation and chatbots. So here is a high-level architecture of the platform itself. If you look at the bottom 2 boxes, VDParrot data source and Azure Cognitive Services, our entire platform is built on open source technologies. We do not use any proprietary software in the platform itself. Having said that, we do use the Azure as a platform as a service in many of these services that we consume as part of the solution. MySQL is one of the solutions that we obviously use this. So we were actually hosted the entire platform on AWS until about 8 months ago. Then we switched, and we were using RDS, which life was a lot easier at that point. And then when we switched to Azure, that's where there's a lot of challenges, because at that time this managed services MySQL was not available, and also because of the security reason and scaling was one of the biggest challenges. Like one of our customers, Wipro, they have an employee base of 170,000 employees globally. So unless you have a scalable solution in place, it is really difficult to support such customers. So that is where this managed MySQL really helped us recently by switching from our own managed MySQL that we hosted on Azure initially. On the Azure ML side, as you can see, we use the LUI intent for intent analysis, LUI framework. We also use Vision APIs for OCR processing. Text analytics is another one where we use speech to text and text to speech both capabilities. And finally, we also use language translations because several of our customers are international customers, so we use language services as well. So as you can see, both we use platform as a service as well as infrastructure as a service. And as I mentioned, most of our deployments are on the customer's Azure subscription. So that is where the scalability and easy deployment through the scripting is absolutely critical for us, without which it would have been really a monumental task for us to do manually. Here is a high-level deployment architecture. As you can see, the list of platform as a service that we use: MySQL for cloud, Data Lake, Azure AD, Louis. As I mentioned, these are all the different ones. Actually, we even use video indexes. This is becoming a big use case where one of several of media companies where they give us the videos, we run through the backend engine to transcribe the text, and then extract the metadata and auto-classify them so that they can make it available to end consumers through this classification that we use. And the infrastructure as a service, here is a list of items that we use on the, again, everything is on Azure now. And probably I think we have about 8 to 10 private deployments on Azure, specific to each customer's Azure subscription. Just a few bullet points here. Initially, as I mentioned, we started with our own. We just took the VMs and then installed MySQL. We ran into lots of problems, and we were really eagerly looking for a solution, MySQL on cloud, which really helped us big time. Obviously, there were a lot of challenges. We were one of the first ones to get onto this infrastructure, and we had several challenges initially. Even at one point in time, for whatever reasons, the whole servers, everything got crashed, and then we restarted the whole thing. But it is very stable now. We are deploying at several of the customers together. The main benefits for us is security is one, scalability is the second thing, is availability. These are all the three focus areas for us why this MySQL on cloud is really helping us big time. That's about it. Thank you so much, and if you have any questions, I'll be available here.
Test. Test, test. Cool. Thanks, Anil, for joining us. All right, so let me switch back to the slide. So I'm just going to briefly talk about how we, as our service, our MySQL service, integrates with other Azure services, and this includes like Power BI, AKS, which you guys probably heard a lot about in the last few days, and as well as, more and more Azure services that we're trying to integrate with to make sure that your lives as developers are much easier. One of the things that we've been concentrating on is kind of integrating deeply with app services, because we know a lot of app developers are using MySQL in the back end. So one of the things that we've been doing is working closely with the app services team to make sure that wherever there's a database that needs to be kind of deployed in the back end, that all of that is part of the developer workflow. And as you walk through either the portal or through your CLI experience, you can deploy a MySQL server in our service along with the app service that you're looking at. So let me go ahead and jump into a quick demo, and I can show you how easy it is to deploy a WordPress application running on app services and have a MySQL deploy alongside with it and connect to it with tools like MySQL Workbench. And I'll show you how if I create a blog post in my WordPress application, then I can actually see it on the back end. So to actually create a WordPress, a new WordPress site, super easy. So I'm in the marketplace right now. Do you guys need me to zoom in a little bit? So we actually have a few templates available. So the one I'm going to show you is the Linux one, if I can search. All right. So what this is doing is it's going right into the marketplace, and you can see here there's two available. WordPress is by default, it runs on a Windows VM in the back end. If you select Linux, then you're paying for a Linux service plan. So let's go ahead and try Linux and click on that. Hit create. All right, so here I'm just going to name it something. So we'll call it Andrea build demo, for example. And I'm just going to select a new, create a new resource group along with it. Here in my app service plan, I can actually select where I want this to be deployed. Oops. So right now the default is West Europe, so I'll just leave it at the default. If you have an existing app service plan, you can just add on to it or create a new one. So I have one in West Europe, so I'll continue on. And here you can see that when I actually select database, I can actually create a new MySQL server in the managed service here. So creating this just requires you to create a server admin login as well as a password. So I'm going to provide this with a password. Confirm it. And here you can see that I can actually select what version of MySQL. Oh, it's popping up on the side. So right now we support 5.6 and 5.7, so the default is 5.7. And then I can actually select the size of the database that I actually want to create and what pricing tier I want to create this database in. So the default is our general purpose with Gen 5 in our West Europe region. And I'm just going to leave it at the default, which is 2V core with 5 gigs and default configuration for backup retention period of 7 days. And I can actually change the database name, but I'll just leave it as is. And Jan will dive into more detail later on about some of the configurations that you can pick for your database. So let's hit OK. And we'll hit create. And this just validates that everything that I've passed in is a normal parameter, and validation successful, and it's deploying right now. So it usually takes maybe like a few minutes to create. Last time it took me about 3 minutes. So you can obviously track the deployment in progress, and you can actually, when you click on this, you can actually see what it's creating on the back end. So you can see here right now it's accepted that it's going to create a MySQL server. And if we hit refresh, you'll also see that it's going to create a website called Andrea Build Demo here. All right. So if I actually click on the resource, Andrea Build Demo, you can see obviously the parameters I selected earlier were in West Europe within this resource group, Andrea Build Demo, and this is the URL endpoint for the WordPress application that actually gets deployed. So let's click on that. It might still be waiting for the database to be created, so let's double check on the deployment real quick in progress. Yeah, it's still deploying the database. Doesn't matter, I have a backup available. So I actually did this before we came into the session. So this is, again, the same thing, the same flow that I walked through, which was to create the WordPress application as well as the database, and obviously an app service plane that gets deployed along with it. So let's go ahead and look at the one that I already have existing. So again, a URL that I get pointed to. Let's give this a moment. Okay, so this is your very generic WordPress template that gets pushed onto your app service, and then this I can walk through to actually set up WordPress. So let's do that really quickly. Andrea's blog, and we'll just say Andrea. This is an intense password, so it's a weak password, but that's okay. And we'll install WordPress to this. Oops. Confirm password. I don't know what it's yelling at me about, but let's see what's going on. It's still asking for a password. Nope. Okay. Sorry guys, demos never really work for me. Back to the portal. Oh, I hid the tabs, yeah. Edge, guys, Edge. All right, let's try this one more time. All right, let's click on this again. It should be working now. Cool, so created the site, Andrea's blog. Great, so now that you have a WordPress site deployed, right, what do you do with it? Well, you wanna create a blog. So we can log in, and we'll give it the same username and password that I just gave in the previous screen. Who remembers the password I put in?
You put in the email address.
You guys have done this before me. Doesn't like it. Oh, well, let's test this. We're doing this live. Oh, no. Okay, well, that's okay because I was also deploying another one, right? Let's switch back. And we'll find the one that's for build. There we go. Build. There we go. Andrea build demo. Cool. So obviously, jumping back into this. All right, we'll go to this. We'll try this one instead. All right, English. This time I'll try to remember what I'm doing. Andrea's second blog. Andrea. This time we'll change it to something simpler so I can remember that. And all right, let's try this one more time. It was build demo all lowercase. You guys can help me remember that. Very insecure passwords. I hope that you choose better passwords for your own applications. All right, so while that's installing, as you can see here, I mean, other than me trying to set up WordPress, the actual flow of actually trying to provision the WordPress application, as well as the database was just kind of like a click, click, click type of installation. So like I mentioned, one of the things that we're trying to do is to ensure that, you know, as low of an overhead as possible for you guys to actually deploy everything that you need. So let's log in again. All right, cool, we're in. So like I mentioned, I wanted to create a new blog post. So let's go ahead in here and we will, you know, welcome to our session. We'll call it like Build 2018 is awesome. And I'm just gonna publish. And obviously one of the things that we want to do to validate that it actually gets written into our MySQL database is to actually query MySQL. So I'm going to jump back over here and I'm going to grab our connection string for the MySQL database. One of the things I'm going to want to make sure that I actually enable is I'm just going to open the IP addresses. So this is also very insecure, so don't do what I'm about to do in your regular day-to-day life. I'm sure you guys are smarter than this, but this basically just allow all IPs to connect to my database. So I'm going to jump to MySQL Workbench. I'm going to create a new connection, and I'll grab the host name from our overview here in the portal for the MySQL server. Yes, I have it running locally.
Okay, so any third-party tool.
Yeah, so
But
like,
you're going over the internet, right?
yes,
Not over a VPN, right?
not over a VPN, no.
Do you
So,
have the option of going over some sort
yes, we have VPNs and VNet endpoints, and Jan, I think, is going to talk about that in a little bit. Yeah. So obviously what I'm doing is very insecure because I did allow everything to access my database. But let's go ahead and we'll... And my username, I can again grab right from here. Copy that over. And let's test the connection. Oh, I know. Let's just turn SSL off for now. And apparently I just can't remember any of my passwords today. So we're just going to do this. Build. All right. That's going to reset the password. So again, something that I wasn't meaning to demo, but you can just do all of this kind of admin stuff straight from the portal. Along with the portal, there's a bunch of different things that you can do to configure your database. So if you explore kind of like the connection security and stuff like that, as well as you can change the storage as well as the vCores and your pricing tiers all within the portal here. So let's double check to see if that actually worked. There you go. So let's connect to it. Okay. We'll make sure we store the password in Vault so it doesn't happen again. And we'll hit OK. All right. So let's connect to the actual database that was deployed. Cool. So the table that I'm looking for is posts. Let me just query that real quick and I'll show you guys. All right, so if you guys squint, because I can't really zoom in, I don't have zoom in unfortunately, but you can see here that it kind of created two rows. So the first row is kind of like your draft post, and then the second one is the actual post that gets published to the blog, and you can see that it's the same blog that I had kind of created from our WordPress application over here. So all in all, the big takeaway is just we're trying to make things as easy as possible for developers to kind of create their MySQL servers in our service along with any of the other Azure services that they need, and just make it as simple as possible.
All right, thank you, Andrea. You'll notice all the trust I was trying to build and saying we're super secure, right? And then Andrea comes up, violates all the security best practices we have, right? So don't repeat this into your systems, but do it similar. No, just kidding. Thank you, Andrea, for demoing this. All right, so let's look at some of the capabilities and also touch on the high availability. So as Andrea showed right now, we support 5.6 and 5.7. We're working on 8.0. It's going to be a matter of a few months until we have support for this, right? Weeks, even better. This is making up for the security. Okay. So yeah, so these are the supported versions, and relatively straightforward. So whatever you use, you should hopefully have an option to go and find on our service. So not, yes.
MariaDB, it'll be version 10?
Yes. So now, high availability. And so with elastic scaling, I already showed one part of the elastic scaling, which was the storage part. I'm going to show you the compute part a little later. But let me walk you through how this works. So who's familiar with SQL Database? No? Okay, so pretty much everyone. So what we're doing with these services, we built on the foundation that SQL Database uses, right? So we didn't reinvent the wheel with those services, but we used the same foundation under the covers. And what this does is it's an architecture where we have a management service that monitors the whole thing. And then when you connect to it, you connect actually to a gateway. And then the gateway finds where your server is located in our clusters and connects you to the server. This is the reason why, so we're not very proud of that one, but you need to specify an @ and then the server name as your username when you connect to the MySQL server. So that's actually the one tiny difference than connecting into a plain IIS MySQL. So you need to specify this. The reason is that the gateway intercepts this, the call, looks at this server prefix, and then looks up where your server is. So what happens is you just run in the service, everything is fine. Now you want to do a scale operation. What we do is we first spin up another instance for you, essentially, with a changed compute size. And then once this is up and running, we do a shutdown on the previous one, reattach the storage, and then you can connect to the newly created one again. Right? This orchestration we do to minimize the actual downtime, and this is what I mentioned earlier, where in a compute or in a VM case, you would essentially shut down the VM and then spin up the new VM and do the failover that way. If you just scale the VM size, right, that's what would happen. And so here we orchestrate this to minimize the actual downtime that you have. The second thing, as I said, I already showed it, is when we scale the storage, it's a pure online operation. right? As you've seen, the workload doesn't get interrupted. We scale the storage below you, which gives you more space as well as the more performance. One thing to note here is storage you cannot scale back down, right? Because we don't actually know what's happening in within your files, essentially, what are the pieces that are used, so we can't shrink them easily without basically taking risk of deleting something that we don't want to delete. So storage is essentially a one-way thing, but computing can scale up and down on the fly. So now I mentioned we use the same mechanism for high availability, and that goes to your question. So what we do here is these services, they don't run on a VM directly, but they rather run in a container. And there's a container technology that was developed to run SQL Server on Linux, actually. So it's a Microsoft proprietary container technology, which has been basically by Microsoft research and our security folks being stamped as a secure container environment. So other than, or compared to other container technologies, this is actually like deemed secure, just because of the way how this is implemented. So what we do is on our end, we run a multi-tenant environment and we spin up individual servers within those containers. And the advantage of this is that for high availability, we don't need to provision a second server and set up replication between those. And that is because we can spin up a new service, like in case of a failure, right? So you run a command, there's a bug in MySQL, the thing crashes. Our management service detects this crash and spins up a new service for you. And this is just starting a process, so it's very fast. And then the same mechanisms that kick in the plan failover case where you scale the storage is we basically attach the storage, the database recovers, and you're back up and running. And this is so fast that we can give you a 99.99% uptime SLA without having to spin up 2 servers. We believe this is actually a quite significant advantage that we have over running an IIS and other systems because ultimately this saves you cost because you don't need the additional replicas unless you really want them, right? For example, read scale reasons. Yes, please.
And when you say it's so fast, is there a general estimate of how fast that actually might be to do that switch over?
So the actual switch over is about 45 seconds-ish, and then the part that we can't really predict is the recovery time, just because simply that depends on the workload. And you will see in the second part of the scale demo that I'm going to be doing, just simply because of the nature of the workload that is running, it just takes a while. But I'll talk to it in a second. But it's essentially if you have a database where you just permanently read, right, never change anything, it's going to be very fast because all these changes are persisted through checkpointing in the process before. If you have like running large updates, how I do it in the workload, then you need to basically recover and replay the log from your last checkpointing. So that just takes longer in the recovery process. Yep. Any questions on that? Does that?
Is your backup capability a function of the container or like a snapshot of the file system? And is it done in real time while the database is running? Because we've got like 24/7 databases.
Mm-hmm.
We actually do our backups from Replication service,
Mm-hmm.
which we can take down, safely back up. And then how is restore handled if you had to restore yesterday's?
I'll show you, yeah. But it's running transparently for you in the background, yeah. Cool. Coming back to security, I need to build up the trust again that Andrea, anyhow. So basically, when it comes to Azure and security, so it's like given that we're running in the Azure ecosystem overall, there are other than the security that we provide on the server itself, and I'll talk to this in the next slide. There's actually a set of layers of security that even happen beforehand. So the very first thing that happens when you connect to Azure is that you need to pass our network. There's essentially a network boundary, right? So any traffic that goes into Azure is being monitored and is being monitored for attacks, DOS attacks, these kind of things, right? So before you even hit our services, there's a layer of protection that happens at the edge of the Azure service, right? Then the second piece is essentially the authentication on the gateway. And again, the gateway has similar capabilities for brute force attacking, stuff like this, right? So that's the second layer. And then the last layer is the authentication of the actual MySQL server. And so this is kind of like when we talk about security, this is a concept that we not only apply to the individual services, but it's like a Azure all-app integrated concept that obviously applies to all services, but specifically also to the database services. Now, the security features on our side, we just use the native database engine authentication, so we don't do anything special there, simply because, again, for full compatibility with that tiny exception of the @ sign. Then when we create servers, we create them what we call secure by default. So you saw Andrea having to make a bunch of settings before she was able to connect to the server. And this is because we essentially lock it down by default. So there's no firewall port open. There's SSL always turned on, right? And obviously then you created a user and a password as part of your setup process. We make sure that the password isn't too simple, and although Andrea had obviously ways to trick this. But so this is, when we talk about secure by default, these are the things that we put in place to essentially protect you, right, from making mistakes. And we make it explicit for you to essentially open up very deliberately to like what you want to let in and how you want to let it in. We said we have service VNet service endpoints. So are you familiar with the SQL database VNet technology? No? Okay. So how this works is the PaaS services in Azure, what we provide essentially a service endpoint that you can inject into a VNet. And then what happens is you can specify for your PaaS service a specific set of firewall rules that is geared towards the subnet that you inject your service endpoint into, and then the traffic is completely limited to the subnet. And it is also we also assure that the traffic never leaves the Azure backbone. So this is the idea of it was also called service tunneling. This is the idea of these service endpoints. So this currently does not yet support having a private IP address within your subnet, but it's the service endpoint technology is also used by SQL Database and other PaaS services. Does that answer your question on VNet? Okay, yeah. So this will go into public preview also in the matter of a few weeks. If you're super eager in trying it out, just let us know, and we can also onboard you onto the private preview. That offer is obviously for everyone, not only for you.
That's specific to MySQL?
The private preview is specific to MySQL and Postgres at the moment, yeah. So Azure SQL Database has the exact same technology as a GA feature already, yeah. So there you can just go and use it, and it's the same technology, and same setup, essentially, yeah.
Does that require anything running, like this probably requires Windows on a client machine, or could you do it from a Linux box?
And that doesn't matter. Yeah. So the service endpoint, the service as like you set up either Linux or Microsoft Windows VM, right? That is part of a VNet and part of a subnet, and then you inject the service endpoint into the subnet. And when you essentially then when you try to connect to the service, it knows to look for the service endpoint. That's how it works. Mm-hmm. And then lastly, like I already touched on the SSL connection, obviously also what we do is we encrypt all data at rest, right? So all the drives are encrypted, all the backups are encrypted, and that's essentially the protection of somebody coming into the data center, grabbing a disk and running away with it, right? So in these kind of cases, people will not be able to use and read the data. And so what we do is we actually rely on the underlying storage technology, and Azure Storage encrypts the data that is stored on the disks. All right, so now I got a couple more slides. However, we thought it may be good to just show you.
Can I just ask this?
Yeah.
How is key management handled for that? Let's say someone did steal a drive or a key was compromised. How do you select a new key and re-encrypt data when it's been?
The keys are being rotated. So I think there is a, I'm not sure if it is a 70-day, or is it?
The key management is automatically generated by the system, so there's
Yeah.
no human element, so human touch for the key rotation or basically a robot.
And how would that affect long-term backups? Like if we wanted more than 7 days, something a year ago, for instance, that data is also encrypted using the keys. How does that all?
No, the keys are managed by the system itself.
Okay, so there's
Yeah, it gets, yeah.
Okay.
Cool. So, show in the portal or on the slides?
Yeah, just,
Portal? Okay.
and can I just ask a question about the HA that you're looking for?
Yeah.
So with Cosmos DB, we now support multi-master write instances. Is there any plan to add that anytime soon for MySQL or Azure SQL Server or anything else, so you can actually do geographically dispersed active instances potentially with conflict handlers?
Well, that's why you have Cosmos.
Well,
No, but so Sunil, right? He's the boss, so he's like, no, but short term, no. Is the short answer to your question. What we're doing is we're gonna have a slide on it. The first step for us to do is read replicas for MySQL specifically, so you'll be able to do readable secondaries essentially within a region. The next step. Be careful what I promise because Andrea will otherwise be yelling at me. But then the next step after that one is to be able to allow this geo-distributed in different regions to cover some of the basically reduce latency with local reads and stuff like this, right? With the multi-master, that's obviously a nice to have thing. It's also slightly more difficult to do. So there's no, unless I'm wrong, there's no immediate thinking on getting this done easily. There may be some things that we can do, but it's not yet basically a committed feature. I mean, it's not an uncommon ask though.
I mean, let me give another color to this as well. And that is like our strategic decision for these managed services that we're using built on top of the community edition, right? So when you look at the industry that are provided in the market that is offering multi-master capability, either they are proprietary variations of MySQL and none mostly are built on top of the community MySQL, except for a few, like Galera, for example, is just like one that I can think of that offers similar multi-master capability or built on top of community MySQL. But there are so many variants which are, they're all proprietary MySQL compatible, but not MySQL community. And that's the reason why we are limited in terms of how we can bring such engine capabilities on top of the managed service. But we are in discussion with some of the partner options like Galera, for example, to see how we can bring them on to get them built on top of us.
So the read replicas you're talking about are Azure technology, not the built-in replication.
No, it uses the built-in replication. Yeah.
Does it support features like slow replication or delayed? If somebody goes and accidentally drops a table, that's what slow replication is for. So you have a grace period where you could go recover from the replication.
Well, that I'm not aware of, but Andrea looks like she's also not aware of it. But let's take that, like we can dig into this more. Obviously, we allow you to do point-in-time restore. And let me talk about this. Maybe that may solve your use case, but I don't know. But yeah.
Just curious if we had control over configuring the replication.
Yeah, I honestly don't know. Yeah, Andrea, that's an item on your list now. So let me quickly talk about backups and how we do it. So you've seen the screen already in Andrea's demo earlier, and I'm confused for a second here, but okay. What you can do is configure the backup retention period. So the default is 7 days. What we do there is we take backups, and it goes to your question. We take essentially backups every 5 minutes. And different types of backups that we take along the line is like a full backup incremental log backups. And so what this allows us to do is to provide you point-in-time restore capability to any second within your retention period. So if you basically go in and like drop a table by accident, you in the worst case have to wait for 5 minutes, which is basically where we take the next backup. But then you'll be able to restore to any point in time within this time window, and a second granularity. So you can, like, if you make a mistake at I don't know 11:15, right? Then, like, again, in the worst case, you wait 5 minutes and then go back to 11:14:59, and your table will be back there.
How is it actually, is it a snapshot, file system snapshot?
No, not at the moment.
No, so then is it locking files as it does the backup?
It does not know.
So how does it prevent orphan records and stuff? Like, let's say it's taking the backup while it, stuff's hammering away at it, and there's records going in one table that have dependencies on records going in another table. How are you preventing the restore that you might have to do from being corrupt because of missing records and stuff like that, or partially written stuff? That's the part I'm not really understanding.
Yeah, exactly. Let's take that offline, just simply because otherwise we're going to be running short on time. But yeah, we can walk you through this. So what you can do is you can change the retention period to up to 35 days, which then gives you the capability of storing or restoring to any point in time within the last 35 days. Now your next question will be, what about long-term retention backups? That is something we don't yet have built into the service. So there, the workaround is currently you need to do a MySQL dump essentially and store these backups for now. It is on the roadmap to provide long-term retention backups as SQL Database has it.
I have one other question. What we've got some tables that have about 1.5 billion rows. They're about 120 gigs in size. You could never ever use a SQL dump. It's not so much dumping the data that's the problem. It's if you ever had to get it back in, you're looking at weeks to read it back in. So what we do is we stop a replication server, we back up the physical files, takes 15 minutes. Then if we have to put it back,
Just do a reattach.
It's quick and reliable.
Yeah.
So that's why I'm wondering, are you actually
It's a problem we will have to solve.
file level backup?
No. But so no, the restore operation takes some time, right? Because we need to essentially apply, like we take the full backup, apply the incremental backups, and then apply the log backups up to the point that you need it. And so yeah, replaying the log is obviously an operation that requires I/O and compute and just takes a little bit of time. And it's depending, as you said, it's depending on the size of your data, how long this operation will actually take.
To answer your question,
Yeah.
just to keep it very simple, so we can dive into the how it is actually working. When the service is doing backups, they're not doing a MySQL dump.
Good, okay.
Right?
That-
So the service has implemented its own backup and restore mechanisms so that we can scale
At the file level.
At the file level.
Perfect, that's good.
But what Jan is essentially saying is that if you want today long-term retention from the user perspective, we don't expose whatever the APIs that we're doing in the backend. So you're limited to what MySQL provides, and then MySQL does.
Yeah. The other thing to point out here is we allow you to store the backups in two different ways, which is locally redundant, and the other one is geo-redundant. So the key difference between them is the local redundant backups allow you to restore at any point in time, but within the region, right? So if you just plainly after oops recovery, like typical development environment stuff like this, we just deleted something by accident, you want to get it back, right? So this is where locally redundant will help you. If you're also after disaster recovery, essentially, and it goes a little bit to the scenarios that you mentioned. Like what you can do is use geo-redundant backups, and what we do is we store the backups not only in the region that you're in, but we also store it in the Azure geo-paired region. And so what it allows you to do with this is you can restore from those backups in the geo-paired region to any other region in Azure. So if things like, I like to use the example, if Godzilla comes and stamps onto Japan, right, and unfortunately hits our data center, and you have geo-redundant backups, you can just restore your database into any other region that is still available, and you're going to be back up and running. There's the restore point objective is about an hour, which is the delay that it takes for Azure storage to get the data into the other data center. So in the worst case scenario, you lose an hour, and then obviously something that you would have to factor in is the restore time of your database that you would potentially have to take as an additional downtime in case of such a scenario actually happen, which hasn't so far. But these are the two different storage options that you have for backups. Okay, any questions on backups?
Is there any feature for recovering from bin logs, or is that just left to the user to manage if they were trying to recover from a failure?
Not quite sure what you mean by that.
Like if it goes, there may be data in the bin logs that hasn't actually gone into the tables yet if there was a failure. I'm imagining that's up to
The service will recover this.
It will
Yeah.
automatically?
Yeah. So in case of a failover, we do replay the log up to the last consistent stage. Yeah. Okay. So let me quickly show you some stuff on metrics. So we provide a set of metrics that you can monitor. And so this is the database that was running the workload that I showed you earlier. And what happened is while this was bound by I/O initially, and you saw that the rate and the throughput went up when I changed the storage. Now the workload is actually CPU bound, which is like now you don't max out the storage IOPS anymore. You have ample capacity there, but you max out on CPUs. So what I'm going to show you, and this is essentially the second part of the scale demo, is I'm going to show you how you can automatically react to such a change. So I'm going to create a alert on a metric. Who's familiar with alerts? Okay, some of you. So basically, what this does is it allows you to specify alert. Hope I never use that name. What this allows you is to specify a rule on a specific metric, and then once this rule is basically, or like once the metric reaches a certain threshold, this alert gets fired. And so you can see build scale demo as my server. And if we scroll down here, I'm going to choose the metric CPU percent because that's what we're interested in. Then you can say the condition, and you can say greater than, greater equals, less than, and so on, right? So we choose greater equals. And for this thing to happen very quickly, I'm going to choose the threshold of 1%. Obviously, that doesn't make any sense for a production system. But for the sake of the demonstration, and this alert should fire when this happens within or over the last 5 minutes, which is the smallest interval. So you can say, hey, if my CPU percent was over 1% in the last 5 minutes, please fire this alert. And then you have different ways of hooking up with this. So you can have an email sent to you. You can call a webhook, or what I'm going to do here is to call a logic app. There's no specific reason, or there is a reason why I'm choosing a logic app. We have a CSA that actually implemented this for us as for demo purposes, and we're just reusing this demo, and we're going to publish this. So what this does is the alert will call the logic app, and then the logic app will trigger a scale operation on the database. So now I press OK here. The alert is being created, and while that happens, I'm going to switch or turn on this window again, and hopefully if everything works, and we haven't been super successful with demos, you will see in just a second that all these green little thingies on the left there, they will turn purple, which means the connection was lost, and I will try to reconnect. And this is when the actual scale operation starts on the compute side of things. And so, last fired 3 minutes ago. That seems not accurate, right? Ah, there we go. Okay, thank you, Jan, for missing it. So now you can see the scale operation started, right? All these connections are essentially dropped, and now what kicks in is in the background the service detected, or basically the service got the request. We spun up the new compute, and now given that the workload is just doing huge updates, right? Essentially, all of this stuff is in the log files and needs to be recovered, and so this just takes some time. I'm not going to wait because we actually otherwise going to run out of time here. But you will see at some point this will come up, and maybe at the end of the session it'll just switch over, and then the instance will be scaled from 2 cores to 4 cores. And it will actually, like given that I put 1%, it will actually continue to scale it up all the way to 32 cores, and I will get a huge bill at the end. So you need to be careful with these things. But like that's the idea. So you can, like I guess what I'm showing here is like you can automate this if you want, and you can scale down as well.
Is this all priced using that same request unit pricing at Cosmos?
No. This is based on vCore and storage that you provision. So if you look at the pricing tiers here, so you can actually see the like how you provision it is with vCores and storage. These are the essentially the compute and the storage that you choose, and then it's a cost per vCore, and it's just a multiplier on top of the vCore, and then it's a price per gigabyte that you provision. And you can provision in 1 gigabyte increments.
But you're being charged for throughput as well somewhere, right? It's not just storage and CPU.
It's just storage and CPU.
So no throughput charges?
No. There's a like if you take data out of Azure, you get get charges for network traffic, outbound network traffic, but that's not service specific. That's in Azure all up.
From Cosmos, right? Because
Yes.
just uploading 120 gigs, there's an immediate cost. Okay.
Yeah. All right. So let's switch back to the deck because Andrea wants to do more demoing. So like the things that I just talked about, there are slides in the deck. I'm obviously now going to jump over them because we already touched them. There we go. This is the read replica stuff I mentioned before. So there are going to be two things. One is data in replication, which allows you to set up replication from on-premises into the service. So that's the use case where you want to have like a readable secondary in the cloud. And the other one is going to be readable secondaries within the region, and will allow you up to 5 that you can connect to and have read workload run against. All right, any questions on that? No, thank you. Where is it? There we go. Oh, best practices also. Which one do you want to see? Do you want to talk about best practices, or do you want to talk about getting your data into the service? Any favorites? Migration? Okay. Then best practices, we're going to skip, and then Andrea, come back up.
Sorry, Sunil, I know you like best practices.
Yeah. This was Sunil's slides. He's going to be very disappointed. Yeah.
Okay, well,
Take it from here.
hopefully
You need to, unfortunately, make it fast.
the demo works well for me, and I'll just, this afternoon, my demos don't like me. Yeah.
There's no dependency on any particular database engine. Like you could use ExtraDB, ARIA, NODB.
NODB.
Really? That's okay. That's not good for us. Do you have plans to support other?
I mean, we are open to the idea.
Oracle proprietary memory.
Yes, that's the reason why we are accelerating our
So even on MariaDB, it'll be NODB.
yes, because
Do you want to do this? Show the
but of course, there are so many options available, but, okay, yeah. We just got to like plug and play today.
That's it, right?
But it is a real dependency, right? It's not just some new technology for sure has dependencies on NODB, or is it just a decision?
All right, hey guys, can we do this offline? Because I just want to show the migration and how simple it is, because that's important and a big takeaway. So what we have available today is the Azure Database migration service, which Xiao works on. So if you guys have questions, we can bombard her afterwards. But basically, the database migration service supports a bunch of different things and a bunch of different source pairs. So right now, what we have available is SQL hosted on-prem or in another, I think in another cloud like RDS, for example, SQL Server to our SQL managed instance service, which is available now, as well as SQL to the Azure SQL Database service, and then like, for example, Oracle to SQL Database. And what I'm going to show you today is how to migrate from a MySQL server hosted, we'll just call it on-prem, but technically I have it in a VM hosted in Azure, to our MySQL service. So in the portal, what this looks like, I actually have a migration project available here. And this, you can sign up for a private preview. So if you guys are interested, just let us know and we'll definitely get you guys up and running here. So I have an existing project, and as you can see here, I have a source server, and this is, like I said, a VM that I have hosted in Azure. And I already have a target server that I have created in our service. And what I'm going to do is I'm going to create a new activity. And what this will do is it will actually start a migration, a continuous migration. And what continuous migration means, it's a minimal downtime migration. So what this will do is it will continuously migrate the data from your source to your target until you tell the service when to do a cutover. So this is kind of in scenarios where you have an application that can't afford a large downtime, right? In some cases, if you're trying to migrate from MySQL to a MySQL, you might have to like shut down your server, for example, and then migrate all the data and then switch your app over. What this will do is it allows you to kind of continuously migrate until you're ready to hit the button and you hit the switch and you say, hey service, let's now migrate, let's switch over the application, and you select when you want to do that. All right, so this is just to access my demo. All right. And this is, I'm providing the details for the actual source, which is the MySQL that I've hosted on this VM that I'm actually on already. And this is to actually connect to the target, which is, like I mentioned, is a MySQL server in the MySQL PaaS service. And what I'm going to do is I'm going to just select one of the databases that I have available, and it's an inventory database. I'm going to hit save. And I'm going to just call this activity run now, and I'm going to hit migration. And what this is doing in the back end is, it's starting this migration. So if I refresh this, it's now showing that it's in the migration pipeline. So I'm going to switch over to an app that I have connected. And I have this app that's reading directly from the local database. And so you can see here, localhost, and it's just showing a bunch of inventory that I have for Star Wars movies. So I'm going to switch to two different Python scripts that I have. And this one over here is going to query from the actual MySQL server that I have hosted in our service. So you can see here I'm connecting to a build demo logged in. And so what this will do is it's just going to query the last available order. So it's connecting, and it's going to tell me the most recent order number that I have available. So the last order was number 41. As you can see here, same thing in the app, number 41. All right. And what I'm also going to do on this other script here is I'm actually going to start creating orders in the MySQL server that I have hosted locally. And what we're going to see is, now that I have the migration up and running, let's double check that it is. Let me refresh this real quick. I want to make sure that, oops, go back. And we'll go run now. Good, it's running. Cool. So if I refresh this, good. I can see that it's been running for a minute now. And run back to this. All right, so I'm going to start basically creating new rows inside the server hosted locally. Oops, wrong password, because passwords are not my friend today. What? Sorry, guys. Okay, there we go. Yes, something worked. So this is going to start creating new orders. So you can see here it's creating order number 42. Now it's creating number 43. And so what we're going to try to see here is if the migration is working correctly, what we'll see is that the latest order will actually start to update over here. So let's give it a bit. So you can see here, latest order is now 42, and this is actually the migration happening in real time, basically, to the source server, between the source server and the target server that I have hosted in the Azure SQL Database service. So obviously we're caught up to number 45. And so when you want to finish your migration and you're ready to do the application cutover, what you're going to do is essentially stop all traffic to your source, your original server, right? The one that have hosted locally. So how I'm going to simulate that is to basically stop this script from running. Right, so the last order that was created is going to be number 52. Oopsies, I think I actually cancel it. Control C. Cool, sorry, number 54. Right, and so now what I can do is actually go to my application, and I'm just gonna change the connection string in my application and point it now to the one that I have hosted in Azure SQL Database, Azure Database for MySQL. So let's do a cutover. And I have the host name saved here. Whoopsies. You know what? I'm not the most secure person, so it's fine. But don't tell our security guys. Mark would be upset with me. And I'm going to get the username, which should do that, and connect. And if everything worked well, then you see that we have up to order number 54. So, you know, this migration service is mainly aimed at migrations that need to happen with as little downtime as possible. So if you guys are interested in learning more about this, we can definitely get you signed up into the private preview that we have running right now. And the short link for that is aka.ms/DMS private preview. So now that was the demo. So to close out, we have a bunch of resources available to you guys to take a look. We have the documentation, obviously. You can check out the pricing page. Follow us on Twitter. I'm always randomly tweeting on there, so please feel free to follow that. If you have questions, please ask questions on MSDN, and we also answer questions in Stack Overflow, and we try to address any questions there as quick as possible. If there's specific features that you guys are looking for that's not yet available in the service, you can feel free to provide feedback on user voice. We're also checking that all the time. So if, for example, geo-replication is, one of the big things that you need, you can upvote existing items there or create new ones for things that aren't available. We also have a GitHub repository available just to check out some samples. And like I mentioned, please, let us know if you want to sign up for the DMS preview using the short link here. And please fill out a evaluation for our talk today, and you guys feel eligible to win like an Xbox, or I really want the Spark drone. So if you guys win it, I'm not asking for it, but you can let me know if you get it. But yeah, otherwise, thank you so much for taking the time to join us today. I hope you guys learned something, and if you guys have questions, we'll be around here and you can ask a few more. But yeah, thank you so much, guys.